This is the 1-8 video, part 1. So find where you are in notes for 1-8, interpreting graphs. You're going to be looking at a lot of different graphs today, and you've got to make decisions about qualities that the graphs have. So follow along in notes, slow the video, stop the video if you need to keep up. One of the words you'll see is they'll ask if a graph is linear. To be linear, what we need to see is that the graph needs to be a straight line. So what you would see, and you can put as an example into the show me, is the axes. And then any graph that's a straight line would be considered linear. Any graph that has a curve or a bend or is just dots is not linear. It might ask you what a y-intercept is. Intercept means a place where you intersect or meet something. So it's the point where a graph crosses the y-axis. So on your graphs might help if you label the axes. So the x-axis is this way. So if they asked for an x-intercept, we'd be looking for where it crossed that green axis or number line. But this one's asking for a y-intercept, or it crosses the y-axis, the one I'm coloring in red. So if the question asked you for a y-intercept, you could put this two different ways. So I see this y point right here, and I see it at, you could say there's a y-intercept, we usually abbreviate it, at -3, meaning that's the number on that number line. Or sometimes we want to write it as an ordered pair, and it'll be 0, -3, and that will help us in some of our other graph interpretation questions later on, is to have that as an ordered pair so that we know what x is doing when y is -3. Symmetry. Again, stop the video when you need to record a definition so that it's accurate and neat. Symmetry means a shape would have that quality if we can fold it on a line so that half the graph or half the figure lands perfectly on the other half. So this U-shaped graph has symmetry because I could put a line of symmetry down the middle and every point here would fold over and land on the other half. The S-shaped curve that you see here, I can't do that. No matter how I put this one, I can't fold it so that one part of it lands on the other. So to have symmetry, it needs to be able to be folded over a line and land on itself. And you've seen plenty of symmetry before in middle school, I would imagine. Increasing and decreasing, they're going to ask where the graphs are increasing and decreasing, and it means exactly what you might expect. Part of a graph that's going uphill, but the important part is from left to right. So from left to right is how all this is determined. So if it's going uphill from left to right, it's considered increasing. If it's going downhill from left to right, it's decreasing because those y values, those results, those outputs are coming down in number. So looking at the graph, and again, pausing the video if you need to get the notes in clearly. Looking at this graph, I would say that where it's increasing, and here's how you'd want to put it. So we're increasing. I see it increasing from the beginning up until we get to x is 3 right here. So we'd say it's increasing from x is 0 to x is 3. Then it's starting to go downhill. Starting from that x at 3, it's starting to go downhill, so it's decreasing until that x of 4. So it'd be decreasing x is 3 to x is 4. And this is how you'd write it in homework, by the way. We need to know that you're looking at the x values. Then it's increasing again. So from x of 4 till 5, so we'd say and. I'm running out of room here, so I'm going over here. X equals 4 to x equals 5. Finally, positive versus negative. A graph is considered positive, or part of the graph, if it's above the x-axis. So anything drawn in this upper portion for a graph would be considered positive. Anything drawn below the x-axis would be considered negative. It's neither if it's just sitting on that x-axis. So with this one, I see part of the graph definitely above, over here, and I'm just going to, instead of that arrow, I'm just going to start it here. Coming down to here. Okay, and then I see part of the graph is positive up here, and I'm just going to stop it instead of using those arrows. And then I see part of the graph's negative underneath. So I want to know what x values that starts and stops at so that I can tell. So for this graph, it's positive. I'm just going to come down with a dotted line from x is -1, 2, 3. So from x is -3 till about here, which looks like it's around -2, it's not quite. So this graph is positive. We can call it -1.8 from x is -3 to x is negative 1.8. Then we'd say from 1.8 until the next value over here, it's underneath, so I want to look to see, so until about this x value, it's negative, so I'm going to say that it's negative from x is negative 1.8 to x is positive 1.8, because that's the part of the graph that's under the axis. Then I've got to go back up and add another one to my positive. It's also positive from x is 1.8 until that number that we're saying is at around 3, that x value where that graph stops. Go back and fill in anything and ask to clarify understanding if something in here isn't clear.